Hello friends, this is Laplace transformation lecture 3. Here we are going to solve some problems, different type of problems based on Laplace transformations, and here we are going to use those formula and theorems which are discussed in lecture number 1 and 2. So please, if you haven't watched those two videos yet, please watch the two videos first, lecture 1 and 2. Links are given in the description box, then you will understand better. Okay, so now let's start. Please like, share and subscribe the channel and hit the bell icon so that you get notified whenever I upload new video. So here we are going to find the Laplace transformation of this t plus t square plus t cube. So Laplace transformation of t plus t square plus t cube. So here first let us apply the linear property, that is Laplace transformation of t plus, we can write Laplace transformation of t square Laplace transformation of t cube, right? We know Laplace transformation of t to the power n is given by factorial n divided by s to the power n plus 1, right? So let us use that here. So if you use that here, so in the first case we have t to the power 1, so factorial 1 means simply 1, and s to the power 1 plus 1, that is s square. Then next one, here t to the power 2, so factorial 2 means simply you can write 2 into 1, 2, right? And s 2 plus 1 means you can write s to the power 3, right? So let us write directly s to the power 3. Similarly, factorial here we have t to the power 3, so factorial 3 means 3 into 2 into 1, right? S to the power 3 plus 1 means s to the power 4. So finally what we have got, 1 by s square plus 2 by s cube plus 6 by s to the power 4. So that's our answer. Now let's move on to next question. Now let us solve question number 2. Here we need to find the Laplace transformation of this expression, which can be written as e to the power 5t t to the power 7 by 2 as well, right? So Laplace transformation of e to the power 5t t to the power 7 by 2, and here we are going to apply the first shifting theorem. Okay, so what was that? What was the first shifting theorem? First shifting theorem. According to that theorem, if Laplace transformation of function f of t is capital F, which is a function of s, then Laplace transformation of e to the power at into function of t, f of t, is capital F, which is a function of s minus a. Okay, so that was the first shifting theorem. And remember one more thing, that Laplace transformation of t to the power n, that we have got factorial n by s to the power n plus 1. This factorial n also can be written as gamma function of n plus 1 by s to the power n plus 1. Okay, so factorial n means we can write gamma function of n plus 1, and gamma function of n plus 1 can be written as n into factorial gamma function of n. Then again gamma function of n can be written as n minus 1 into gamma function of n minus 1. Okay, again gamma function of n minus 1 can be written as this one, and gamma function of n minus 1 can be written as n minus 2 into gamma function of n minus 2. That's how we can proceed. Okay, so here you see, in order to apply first shifting theorem here, so what we're gonna do, we need to find a Laplace transformation of this. So first we are going to find a Laplace transformation of t to the power 7 by 2, so which is equal to, according to this formula here, gamma function of n plus 1, gamma function of here 7 by 2 plus 1 by s to the power 7 by 2 plus 1, right? or you can write a gamma function of 7 by 2 plus 1 by s to the power 7 by 2 plus 1 will be 9 by 2, right? So now let us evaluate gamma function of 7 by 2 plus 1. So according to these results, we can write 7 by 2 gamma function of 7 by 2. Again, gamma function of 7 by 2 can be written as 7 by 2 minus 1 into gamma function of 7 by 2 minus 1, right? So we will continue on this method unless we get at the end gamma function of half, because gamma function of half is root pi. Remember that gamma function of half is root pi. So if you do so, then what you will get, let me erase this word. Let me scroll down the page a little bit. Okay, so 7 by 2, then this gamma function of 7 by 2 is 7 by 2 minus 1, 7 by 2 minus 1, 7 by 2 minus 1. If you calculate this, then you will get 5 by 2, right? You will get 5 by 2, then gamma function of 5 by 2. Now again, if you evaluate this gamma function of f by 2, then it can be written as f by 2 minus 1, which will be 3 by 2, then gamma function of 3 by 2. Again, if you apply the same method here, then you will get 3 by 2 minus 1 means here you will get 1 by 2, then gamma function of 1 by 2. So here we have got gamma function of 1 by 2. Okay, so let's multiply all those. Then here we will get 105 by 16, and gamma function of 2 is nothing but root pi. Okay, so now let us use this value here. Okay, let me scroll down. Then what you will get, Laplace transformation of t to the power 7 by 2 is equal to 105 root pi 16 into s to the power 9 by 2. So this is our capital F of s, you can assume that way. So then this is the Laplace transformation of f of t, right? Then Laplace transformation of e to the power at into f of t. That means in our case we can write e to the power 5t t to the power 7 by 2 is equal to f of s minus, here a is 5, okay, so s minus 5, f of s minus 5. So if here you can see, if f of s is equal to this one, then f of s minus 5 will be, this s should be replaced by s minus 5. So hope you have understood this. Then we will get 105 root pi 16 into s minus 5 whole to the power 9 by 2. That's what we will get. This is 5, right? So let me write clearly. S minus 5. Okay. So this is question number 2. Now let's move on to question number 3. So here we need to find the Laplace transformation of sine cube twice t. So if you remember this formula, that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta, then it implies that sine cube theta, from here we can find sine cube theta is equal to 3 sine theta minus sine 3 theta divided by 4. Okay, so if you apply this one here, considering 2t as theta, then what you will get? Then we will get Laplace transformation of 3 sine theta will be replaced by 2t now, then minus 3 sine 3 into 2 theta 2t, sorry, that means 6t. We can write 6t divided by 4, that's what we can write, and which can be written as 1 by 4 3 Laplace transformation of sine twice t minus Laplace transformation of sine 6t, right? And 1 by 4 3 sine 2t, it's Laplace transformation. Laplace transformation of sine at, we know that that is equal to a by s square plus a square. So if you apply that, then what you will get from here, you will get 2, instead of a there is 2, s square plus a square is 2 square, here it will be 4, then minus Laplace transformation of 6t, here a is 6, so here we will get 6 s square plus 6 square, that is 36, right? We're gonna have this. So now let us take LCM here. You can see if you multiply these 3 with this 2, then you will get 6, right? So let me write here directly 6. So you can write 6. Okay, so it is 6. Now 6 can be taken as common, 6 by 4. Then let us take LCM here. So what you will get, s square plus 4 into s square plus 36, sorry, and here as a numerator s square plus 36 minus s square minus 4, that's what you will get, s square gone, right? So here plus s square minus s square gone, so we have 36 minus 4, that's gonna be 32, right? So let me scroll down the page. 6 by 4 into 32 by s square plus 4 into s square plus 36, that's what we will get, and cancel 32 by 4, then you will get 8, then 8 6 48, so our final answer is 48 by s square plus 4 into s square plus 36. So that's our answer. So that is the Laplace transformation of sine cube 2t, which is equal to this one. Here let us solve question number 4. So here we are going to find the Laplace transformation of e to the power minus t into cos square t. So before we solve this, so you know what we are going to do. We are going to apply this identity here. Cos square theta is equal to half into cos 2 theta plus 1. Let us apply that. So here theta is nothing but t in this case. So then what we will get, Laplace transformation of e to the power minus t, instead of cos we will get half cos 2t plus 1, that's what we will get. So this half can be taken out as it is constant, so we can write half Laplace transformation of e to the power minus t cos 2t, then we can write plus Laplace transformation of e to the power minus t into 1, that is e to the power minus t, that's what we can write. Okay, so here you see, in this case, in this first part, we are going to apply the first shifting theorem again. So here you see Laplace transformation of e to the power minus t, and here cos 2t, right? So this is in this case our f of t, cos 2t is our f of t. So Laplace transformation of f of t, that is Laplace transformation of cos 2t that is nothing but s by s square plus 4. 2 square means 4, right? That's what we will get. This is our capital F of s. So according to the first shifting theorem, then Laplace transformation of e to the power at f of t is given by f of s minus a, right? And here in this case a is minus 1 because we have e to the power minus t here. Laplace transformation of e to the power minus t, and f of t is cos twice t, right? So f of s, we have got this. So f of s minus 1, that's going to be, sorry, not a is minus 1 here, so it's going to be plus 1 and divided by s plus 1 whole square plus 4. That's what we will get, right? So that's why we can write half of. So instead of this first part, we can write s plus 1 whole square plus 4 and plus Laplace transformation of e to the power minus t. We know that Laplace transformation of now the second part here, you see Laplace transformation of e to the power minus t. We know Laplace transformation of e to the power at is given by 1 by s minus a. So here a is minus 1, so it's going to be 1 by s plus 1, right? Because a is minus 1. So we get 1 by s plus 1. That's what we will get. Now let us simplify this. So if you simplify this, what you will get, Laplace transformation of e to the power minus t cos square t is equal to what we will get. So here apply a plus b whole square formula, then it will be s square plus twice s plus 1 square is 1 plus 4. So 1 plus 4, that's going to be 5. And if you multiply this 2 here, then what you will get? Then you will get 1 by 2s square plus 4s plus 10, and sorry, not 1 by, so here it should be s plus 1, then 1 by s twice s plus 2. That's what you will get, right? So this is your answer. So that's how we can solve. Okay, now let's move on to next question. So our next question is this. So this is our next question. So how to solve this? So we know that 2 sine A sine B is equal to cos A minus B minus cos A plus B. That's what we know. So that's why sine A sine B will be half of this, right? So hope you have understood this. Or what we can do, we can simply write this way. So let me show you now. So we need to find the Laplace transformation of, sine twice t sine thrice t, right? So here what we can do, we can multiply half and 2, right? Then here we can write 2 sine twice t sine thrice t. Now consider twice t as a, thrice t as b, right? Then what you will get, according to this identity, half Laplace transformation of, so here you will get cos a minus b means 2t minus 3t, 2t minus 3t, that's gonna be minus t, and cos of minus theta we know plus theta, so cos theta, sorry, we know cos of minus theta is cos theta, right? So directly we can write here, instead of minus t we can write cos t, then plus, sorry, not plus, minus cos a plus b. Here a is 2t, b is 3t, so that's going to be 5t, right? That's what we will get. Now half, it can be written as Laplace transformation of cos t minus Laplace transformation of cos 5t, right? We can do that way. Now Here apply Laplace transformation of cos 80. Here a is 1. So what we will get, s by s square plus 1 square is 1 simply, then minus s by s square plus 5 square is 25, right? So you can take a LCM here. So let me show here this part. Sorry. So half, if you take LCM, what we will get? LCM of these two will be s square plus 1 into, this is the next step, s square plus 25, and from both cases you can take s common, right? S into, then s square plus 25 minus s square plus, instead of plus there will be minus, right? That's what we will get. So here minus s square plus s square gone, so half s into 25 minus 1 is 24 by s square plus 1 into s square plus 25. That's what we will get, and 2 12s are 24. So our final answer is, so let me scroll down the page a little bit. So our final answer is, 12 s by s square plus 1 into s square plus 25. That's what we will get. That is the Laplace transformation of sine 2t into sine thrice t. So hope you have understood this. Now let's move on to the next question. So now let us solve question number 6. Here we have to find the Laplace transformation of cos 80 into sine hyperbolic 80. Laplace transformation of cos 80 sine hyperbolic 80. So remember one more thing, sine hyperbolic 80 is e to the power 80 minus e to the power minus 80 divided by 2. So remember this formula. Now if you put here, then what you will get, Laplace transformation of cos 80 into e to the power 80 minus e to the power minus 80 divided by 2. That's what we will get. So if you simplify this, then what you will get, half can be taken out, then you can write e to the power, Laplace transformation of e to the power 80 cos 80, then minus Laplace transformation of e to the power minus 80 cos 80, right? That's what we will get. Again, in both cases we are going to apply the first shifting theorem, right? So what was that? So here, Laplace transformation of if Laplace transformation of f of t is capital F of s, which is a function of s, then Laplace transformation of e to the power 80 f of t is given by capital F of s minus a, right? So here in this case, for the first part, so if you find the Laplace transformation of cos 80, so what you will get? You will get s by s square plus a square, right? So this is our, suppose, capital F of s. Then if you find Laplace transformation of e to the power 80 cos 80, then what you will get, according to this first shifting theorem, then you will get s minus a by s minus a whole square plus a square. That's what you will get, right? Now similarly, we can find Laplace transformation e to the power minus 80 cos 80, right? We can find that. So just what to do here in this case, we just need to replace this s minus a here, just replace the a by minus a, then what you will get, here you're gonna have then plus a, right? Hope you have understood this. So if you replace this a by minus a, then you will get here s plus a, right? Here also s plus a, that's what you will get. So sorry, so let me clean this first. Okay, so now we will get s plus a by s plus a whole square plus a square, that's what we will get. So now let us use these two values here, then what you will get. So let me scroll down the page. So therefore Laplace transformation of cos 80 sine hyperbolic 80 is given by half. So if you replace this first part by this value, you will get s minus a by s minus a whole square plus a square, then minus let us replace the next part, this part, by this value, then what you will get, then you will get s plus a by s plus a whole square plus a square, that's what you will get, right? So this is your answer. Okay, so that's how we can solve this kind of problem. So now let's move on to next question. So let us solve this. Here we need to find the Laplace transformation of sine hyperbolic cube t, right? So here we are going to use this formula. Remember this, sine hyperbolic cube t, it can be written as sine hyperbolic 3t minus 3 sine hyperbolic t by 4, that's what we can write. So if you use this value here, then what you will get, you can write 1 by 4 outside, right? 1 by 4, then Laplace transformation you can write separately, sine hyperbolic 3t minus Laplace transformation of 3 can be written outside, sine hyperbolic t, right? You can use this formula here. Okay, so then applying linear property we get we get this. Okay, so this is 4, so 1 by 4 is taken outside as a constant, then Laplace transformation of this and this, right? So hope you have understood this part. Then Laplace transformation of sine hyperbolic 80 is equal to nothing but a by sine square minus a square. Okay, so let us apply this formula here. So instead of a we have 3 here, this is the a, right? So what we will get, 1 by 4 Laplace transformation of the sine 3t hyperbolic sine hyperbolic 3t will be 3 by s square minus 3 square is 9, then minus 3 into, again here hyperbolic t means 1t, we can consider 1 into 3 is simply 3, so we can write 3 by sine square minus 1 square is 1, right? We get this. So here you see we can take this 3 common, right? If you take this 3 common, then you will get 3 by 4. Then what we are going to do, we are going to take LCM. So LCM of s square minus 9 into s square minus 1. So taking that, what you will get, s square minus 1 minus s square minus minus plus 9, right? So hope you have understood this. There should not be any confusion. So here minus s square plus s square are gone, and plus 9 minus 1, that's going to be 8, right? So then what we will get here, so let me scroll down the piece here, 3 by 4 into 8 by s square minus 1 into s square minus 9, that's what we will get. So you can cancel this 8 by 4, then you will get 2, 2 3 is 6. So our final result is 6 by s square minus 1 into s square minus 9. So this is our answer. This is the Laplace transformation of sine hyperbolic cube t, right? So that's how we can solve. Now let's move on to next. So now we need to find Laplace transformation of cos hyperbolic at sine at. So here we are going to use this cos hyperbolic at is given by e to the power at plus e to the power minus at divided by 2, right? So if you use that here, this 2 can be taken outside, right? So then Laplace transformation of e to the power at plus e to the power minus at into sine at. That's what we have done, right? So here this can be written as half of e to the power at plus e to the power minus at, right? So this half is taken outside as it is constant. So hope you have got this. So now what we are going to do, now let us expand this here. So if you expand this, then what you will get, applying linear property. So here you will get Laplace transformation of e to the power at sine at. Again we need to apply here first shifting, then plus Laplace transformation of e to the power minus at sine at, right? That's what we will get. So let us apply the first shifting. Here consider this one as f of t, then Laplace transformation of f of t, let us find that is Laplace transformation of sine at. So Laplace transformation of sine at is simply nothing but a by sine square plus a square, that is by first shifting formula, first shifting theorem. Sorry, this is not the first shifting theorem. So this is the f of s, right? This is f of s, capital F of s, which is a function of s. Then what will be the Laplace transformation of e to the power at f of t? In our case, f of t is sine at, right? So that means Laplace transformation of e to the power at sine at. What will be that? As we have seen here that f of s is, this f of s is a by s square plus a square. Now replace this s by according to first shifting theorem, it should be f of s minus a. Replace the s by s minus a. So then what you will get, it will give you a by s minus a whole square plus a square. Now here you see what will be the Laplace transformation of, similarly you can find the Laplace transformation of e to the power minus at sine at, right? So simply by replacing this a by minus a, right, then it will be plus a, s plus a. So if you put, instead of, if you replace the s by s plus a, then what you will get, a by s plus a whole square plus a square. That's what you will get. Now let us use these two values here. So let us use this first value here for the first term and this second value for the second term. So then what you will get, therefore what we will get, Laplace transformation of cos hyperbolic at into sine at is equal to, so let us put this one here, what you will get, half a by s minus a whole square plus a square, then plus, and here the second term will be equal to this, right? That is a by s plus a whole square plus a square. That's what we get. So now let us simplify this. So let me scroll down the page. So here what we are going to do, let us take a common, so we will get a by 2. So what we have done, these two a taken common, right? So now let us take LCM. So on taking LCM, what we will get here as a denominator, s minus a whole square plus a square, then s plus a whole square plus a square. So here as a numerator we will get s plus a whole square plus a square plus s minus a whole square plus a square. So here you see s plus a whole square and s minus a whole square. A plus b whole square plus a minus b whole square always gives you 2a square plus b square. Remember that. Okay, so let us apply this formula here. So then what you will get, applying that, you gonna have a by 2 twice s square plus twice a square, right? Then again we have a square twice a square. That's what we will get. And as a denominator, if you multiply these two, this one with this one, that's gonna give you, so here s minus a, we have s plus a, that's a product of that two will be s square minus a square. Again we have squares here, so s square minus a square whole square, right? We are gonna have this s square minus a square whole square. Now what we are going to do, let me show you. So now this should be multiplied with a square, right? Then what you will get, plus a square into s minus a square, s minus a whole square. Then again this a square should be multiplied with this s plus a, then a square into s plus a whole square. Then this a square should be multiplied with a square, so that we get a to the power 4. That's what we will get, right? Now you see, from here it consists to, and 2 can be taken common and can be cancelled with this 2, right? And from here you see a square can be taken common. Then if you take a square common, then you will get s minus a whole square plus s plus a whole square, and that is equal to, we get 2s square plus 2a square. That's what we will get, right? So then, and from here if you expand this, then you will get s to the power 4 minus 2s square a square plus a to the power 4. That's what we will get, right? So if you multiply this a square with this, then what you are going to have, then you are going to have 2s square a square, and here you will get 2a to the power 4. That's what we will get. And plus we have a to the power 4. So here you see this term will be cancelling each other. Then a to the power 4 twice a to the power 4, 3a to the power 4 plus again a to the power 4, 4a to the power 4. So finally we will get as a denominator s to the power 4 plus 4a to the power 4. That's what we will get as a denominator, right? So sorry, let me clean this part. So what we have got here, so let me scroll down, a by 2, and 2 is taken common, and s square plus twice a square. So because twice a square, that's going to be 4a square, and on taking 2 common, we will get again 2a square, right? So hope you have understood this step. By here s to the power 4 plus 4a to the power 4, that's what we will get as a denominator, right? So how to get that, I have already shown, right? So now these two cancels, so our final result is a into s square plus twice a square divided by s to the power 4 plus 4a to the power 4. So this is our final result. That is the transformation of Laplace transformation of this is this. So hope you have understood this. Now let's move on to next question, right? And here we are going to apply the second shifting theorem of Laplace transformation. So what was the second shifting theorem? According to second shifting theorem, if Laplace transformation of f of t is equal to capital F of s, right, then g of t, which is equal to f of t minus a, when t is greater than a, and otherwise it is 0 when t is greater than 0 less than a, then Laplace transformation of g of t is given by e to the power minus s into function of s, capital F of s, right? So here you see, instead of in the question, though I have written here g of t, but here we have f of t, and here we have f of t minus a, and here we have taken f of t. So let us write f of t as g of t and g of t as f of t to compare with the question, right? So let me replace here g of t, and it is f of t, and this is g of t minus a. So let us replace that way. Then what you will get, this is f of t, suppose, and this is g of t, and this is not f of t, this is g of t. Laplace transformation of g of t is suppose capital F of s, and this is f of s, not f of s, a small f of t, and this is suppose small g of t. Then Laplace transformation of f of t is given by this, right? So let us do that. If you compare with this, then what you will get, this is the g of t minus a, in this case cos t minus 2 pi by 3, that's what we got, right? So now in that case, g of t should be cos t, right? So Laplace transformation of g of t here, in this case g of t is equal to Laplace transformation of cos t, and that's gonna be, what is the Laplace transformation of cos t? That is s by s square plus 1 square, that is 1, right? So this is our capital F of s, function of s. So now Laplace transformation of f of t. So here that's gonna be e to the power minus as capital F of s, right? So here you see, instead of a we have this 2 pi by 3. So here a is equal to 2 pi by 3. Then our result is going to be equal to e to the power minus 2 pi s by 3, and capital F of s is here, capital F of s is this, right? So here we will get s by s square plus 1. So that is our result. So hope you have understood. This is the last question. So thank you for watching, and if you have any question that other than those I have solved in this lecture, then you can send me, okay? And to send me questions, follow me on Insta, and this is my Insta ID, ozalekajit123. so you can send me there. So just if you have any problems, then send me within 2 or 3 days, because after 3 or 4 days I'm gonna upload the next video. So if you send the questions before that, then I can solve those in the next video, right? So